Good morning, children. Today the chemistry part, lesson number 2, solution. The topic is the vapor pressure of the solutions in a liquid. Before going into the topic, पहले vapor pressure बोले तो क्या है? Let us see the term. What is the vapor pressure? So vapor pressure is nothing but when you consider or take in a vessel of closed one. ठीक है, एक क्लोज्ड वेसल को लेना है, उसका अंदर पूरा पानी, यू नीड टू पोर द वाटर. नाउ व्हेन यू सप्लाई द हीट, the water starts to condense and it starts to evaporate. When it evaporates, already I have said this is a closed container. So if the water starts to evaporate, it get condensed in the form of droplets. दैट इज़ नथिंग बट एवोपरेशन हो सकता है, पानी एवोपरेट हो सकता है. एंड इसका वजह से ये क्लोज्ड है. सो क्या होता है, जो प्रेशर ये वेपर का जो ऊपर रिलीज हो रहे वो एक प्रेशर शो करता है. दैट प्रेशर इज़ नथिंग बट द प्रेशर विच इज़ present or the vapor pressure which is present on the water or on a liquid surface is called as the vapor pressure. Which exerts which present above the liquid is called as the vapor pressure. So our topic is vapor pressure of solution. Already you learnt about what is a solution. Solution is nothing but solute plus solvent. So let us see about the topic vapor pressure of solution. So all the liquid solutions का अंदर vapor pressure कितना effect होता है. So this can easily be explained with the help of the Raoult's law. So this is explained with the help of the Raoult's law. So let us see what is the Raoult's law. Raoult's law, it is nothing but it states that the partial vapor pressure of any volatile component of a solution is equal to vapor pressure of the pure component multiplied by its mole fraction in the solution. So this is the definition of the Raoult's law. So before going to, let us see some of the terms which are mentioned here. Then we come to what is the Raoult's law. So one of the term is volatile component. Volatile component बोले तो two types of components रहता है, एक volatile and एक non-volatile. So volatile compounds बोले तो which can be easily evaporated. For example, water we can say it as a volatile compound. So जो easily evaporate हो सकता है उसको हमने volatile component करता है, जो evaporate नहीं होता है उसको non-volatile compound बोलता है. So another term coming to vapor pressure, already we have seen what is the vapor pressure. Now coming to the pure component. Pure component is nothing but the substance which you have without any mixing of the compound, which will be of pure, it is called as the pure component. Next, another term already you have learned what is the mole fraction. Mole fraction is nothing but number of a particular substance compared to the total number of moles. So उसका definition क्या है, number of moles of particular substance compared to the total number of moles of given substance. So already you have learned. So these are the some of the terms you need to know. So coming to the Raoult's law explanation. Now listen carefully. This is a container which consists of the solution. So this solution container का अंदर solution present है. So solution when you starts to heat it, so it starts to evaporate. As I said, vapor pressure calculate कर रहे हैं हमने. So ये क्या होता है, एक volatile component लिया. Volatile means you think it as a water, as I said, which easily evaporates. So इसका अंदर vapor pressure, ये प्योर कंपोनेंट का वेपर प्रेशर कितना प्रेजेंट होता है उसको हमने कैलकुलेट कर सकता है. दैट वी आर कॉलिंग इट एज द Raoult's लॉ. सो फॉर एग्जांपल इक्वेशन ऑफ द Raoult's लॉ. तो इस कंटेनर के अंदर पानी लिया हमने, पानी लेके उसको हीट किया तो इट स्टार्ट्स टू एवोपरेट. द एवोपरेट होता है उसको हमने क्या नाम दे रहे, इट इज़ नथिंग बट द partial प्रेशर. सो आफ्टर पार्शियल इट स्टार्ट कंप्लीटली एवापोरेट हो सकता है. सो इसका ऊपर एक वेपर प्रेशर भी एग्जर्ट होता है. दिस वेपर प्रेशर वी आर कॉलिंग इट एज P0, P1 naught. So coming to the equation, partial pressure is equal to P1 naught into mole fraction. This is nothing but the equation of the Raoult's law. By this we can calculate all the solutions का vapor pressure कितना exert होता है. So next coming for the proof, how? By some of the assumption we can prove that all the volatile substance can exert the vapor pressure. So proof, two volatile liquids A1 and A2, two beakers लेना है. टू beakers का अंदर टू solutions लेना है, एक A1 and एक A2, and P1 P2 are the partial pressure which is released after evaporation, and X1 X2 are the mole fraction. P0 and P2 are the pure vapor pressure. Nothing but इसका ऊपर जो vapor pressure at equilibrium stage में एक vapor pressure को exert करता है, that is nothing but the pure vapor. So now coming to the as before equation, now P1 is equal to X1 and P0, and P2 is equal to X0, X2 and P2 naught. So according to the Dalton's law, you have learned before. Dalton's law equation क्या है? P is equal to P1 plus P2. So substituting this P1 value and P2 value. So P1 value is X1, P1 naught. P2 value is X2, P2 naught. And already you have know X1 is nothing but 1 minus X2. This is the equation. So substituting this X1 value in the P1 naught value near the X1. So let us see. Now the equation can also be written as P is equal to P naught 1 minus X2 plus P2 naught X2. Next P is equal to P1 naught minus, so multiply करना है P1 X2 plus P2 X2. So this P1 X2 को हमने निकल सकता है, तो क्या होता है? P2 naught minus P1 naught X2 plus P1. So this is the final equation of the vapor pressure of a given solution. So you can easily plot a diagram comparing the mole fraction and vapor pressure. You can draw a plot versus of mole fraction versus vapor pressure while considering P0 versus X2. So at the place of X2 is equal to 0, P is equal to P1 naught, and X2 is equal to 1 and P is equal to P0. For example, so equation is P is equal to P2 naught minus P1 naught into X plus X2 plus P1 naught. Now when you substitute this value, if X2 is equal to 1, P2 minus P1 naught into 1 plus P is equal to P1 naught. So what will happen? Nothing but P2 naught minus P1 naught plus P1 naught. So P1 naught cancel हो सकता है, P2 naught हो सकता है. So this is nothing but the, by this we can say that vapor pressure. So this is about the concept of the lesson. Thank you.